In this screencast, we introduce hypothesis testing for population proportion with an example. So let's look at an election. Stephen's running for president of Iran, a small fictitious country located somewhere between France and Hawaii. And I commission a poll to see how I'm doing. Polly reports back that she polled 1,000 random voters and that 530 are planning to vote for me. So that's great. That's 530 out of 1,000. That's a majority. But two of my advisors, Happy Holly and Gloomy Gus, get into an argument. Holly says, "Great news! 53% of the voters support you." Gus says, "Let's not get ahead of ourselves. There are 10 million people voting in this election, and Polly only polled 1,000 of them. You might actually be losing the race right now, and Polly just accidentally got a sample with a lot of your supporters." Holly says, "Don't be so gloomy, Gus. I say this is good news." Gus says, "I say it's meaningless. If you poll 1,000 people out of such a large population, there's bound to be some random variation. You don't actually think Stephen has exactly 53% support, do you?" Holly says, "Well, maybe not exactly 53%, but if Stephen isn't winning, what are the chances we'd see 53% support in a sample that size?" So, who's right, Gus or Holly? Am I winning? What do you think? Well, it turns out that Holly's last question is the key. If I'm not winning the election, how likely is it we'd see 53% support in a sample that size, in a sample of 1,000 voters? And it turns out, using the sampling distribution of the proportion, which we have covered or will cover in class, the chance is 3%. And we'll leave the calculations for later and focus on the logic. Gus and Holly are trying to decide between two alternatives. I'm winning or I'm not winning. The 3% tells us that if I'm not winning, then the polling results Polly just got would have been very surprising. They would have had only a 3% chance of happening. That's not impossible, but it's pretty unlikely. So the most reasonable conclusion is that I am winning. At least the preponderance of the evidence is that I'm winning. We can't be sure, but again, if I wasn't winning, it would have been surprising for Polly to get 530 out of a random sample of 1,000, assuming she's got a good random sample. That's crucial, of course. It's not impossible for her to get those results, but it would have been surprising. So in statistics, we use data to choose between two alternatives by asking how surprising the data we got would be under each alternative. If the answer is very surprising, then this provides, under one of the alternatives, then this provides support for the other. So what do you think? If you draw 20 cards from a deck of playing cards and look at each card before returning it, if 19 of the cards are red, does that make you think that the deck is rigged in some way? In another election, Polly polls only 500 voters and 250 favor her candidate. That's a majority, but should she break out the champagne? Your intuition probably led you to the right conclusion. The deck is rigged and the election is too close to call. Statistics is all about making judgment calls when the data doesn't speak so loudly. If alternative A is correct, how should I be surprised by the data I just got? That's the question we'll ask over and over again as we go into hypothesis testing.